All right, welcome back everyone. So continuing on with the World Database Storage System, in this video and over the next few following, we're going to be taking a look at getting the implementation for the actual database store in place. Now, there are a lot of interconnected methods here, a lot of methods that rely on one another, and this could become confusing to anyone that's following along that is more of a beginner to intermediate user. Now what we're going to do is break it up over several videos, and as Nelson works his way forward, starting out with the implementation of get and store, he'll be stubbing out methods that are going to be required, but of course there's going to be no implementation in those other methods, though as we progress through the videos, the meat of those methods will be added in. So keep in mind that we're not going to really see this database store working until we're done with all of these methods that are relied on.
Yep.
All right, so with that, let's get started with it.
And I also want to point out that I guarantee you it'll be 1,000 more times confusing if we just stuffed all of the code required to implement either get or store into a single method.
Yeah, for sure.
All right, so the first method I'm going to implement is this generic get method. And he's actually going to be incredibly easy. Return get, type of tRecord, coordinates start, or coordinates layer, sorry. And then we're going to have to cast him to a tRecord.
Okay.
So yep, that's all he does. Like I said, he's just a generic interface over this non-generic method that exists in case we want to do some crazy reflection stuff and don't want to deal with reflecting on genericized methods. But basically, they both do the same thing.
Right.
So this get method, basically what he's going to do is we're going to start out with an iRecord. We're going to set him to null. And that's going to be the record that we're going to stuff things in if we ever find him. The first thing is we need the first index for our index, which we haven't even instantiated yet. So I kind of want to backtrack just a few seconds because we need to instantiate our file streams and our database index class. So the database index is just going to be new database index, and then we're going to pass in the file system. And alt-enter, no, I don't want a local variable, I want a field. So I just created a read-only field on the database class. Now the important thing to know is that database index actually implements iDisposable. And that means that we're going to have the concept of when do you want the database open and when do you want to finally close it. So just like how database is also going to have file streams that need to be disposed, database is going to have to implement iDisposable. And I'm going to go ahead and implement the dispose method. The dispose method for right now is just going to call index.dispose. The next step is I'm basically going to do the exact same thing we did with the index as far as his file streams. What I'm going to do though is I'm going to write a method called openStreams. And the reason I'm breaking out this method is because we're going to be eventually opening and closing streams as the database exists. That makes sense?
Mm-hmm.
Because, for example, once we start working with things like defragmentation and stuff like that, we'll need to be able to close our streams, work on the files, and then open them back up again.
Right.
So I'm going to write a open streams and a close streams method, and basically all they're going to do is quite literally open streams and close streams. So we're going to have a file stream equals just like whatever it's called, the index works.
Just exactly, just like in the database index.
File mode is going to be open or create, and our file access is going to be read and write. Then we're going to need a reader, and he's going to be a binary reader. And then we need a writer, and he's going to be a binary writer. And then I'm going to do this slowly. Alt-enter, F. This will create a field based off of what ReSharper could infer. Now here's a problem. Our cursor is all the way up there. I don't want to bring my cursor back down to this reader so I can Alt-enter on him again. But you notice he's red. That means he's a ReSharper error. There's a neat little key combination that I used during the database index to make all these things fly out of nowhere, where I can actually position the cursor on the next error down or the next error up. And that's going to be Alt, page down, or page up. So you see how that works?
Mm-hmm. Very nice.
So basically what I can do is, if this returned null, so we don't have to deal with that stuff for now, basically I can just really quickly Alt page down, Alt enter F to create a field, Alt page down, Alt page down, Alt enter F to create another field. And so now we've created 3 fields based off of usage.
Very nice.
And then we're going to write our close stream methods, which, if you haven't guessed, I'm actually going to close this last. Is going to do that. And then we're also going to close our streams when we dispose ourselves. So yeah. Now we have that out of the way, we can start again on our get method. And the first step for our get method, like we showed in the initial overview, is going to be getting the index of a record. So basically we can say first index equals index, get first record position for these coordinates. And then we can say if first index is -1, just return out null. I don't know why that's up there. This should be down here. Okay. The next thing we're going to do is we're going to use our walk
You've got it there.
List. And walk record list is going to be implemented at some point. But basically what what this method does that hasn't been implemented yet is that we're going to pass in the first index that should start at, and then for every record that it finds in this record list, and remember I'm using the word record list like the linked list that starts off at the first record position and then goes to the next record, next record, next record for those particular coordinates. What this walk record list method is going to do is it's going to go ahead and invoke this delegate in the form of this lambda here every time that it hits a record. And it's going to start at this index. So walk record list is going to also, the delegate is going to have a Boolean return type. And that Boolean return type is basically going to say, do we want to go to the next, or do we want to, how should I word this? Do we want to stop? So that's what the question is for the return type. So if I were to say return true, this would signal a walk record list that we need to stop. If I were to say return false, this would signal to the walk record list that we need to keep going on this list. So with that in mind, we can go ahead and say if header, and header is, again, that's the variable passed in from the delegate, is going to be the current header we're looking at. And we're going to say if header type does not equal type, and, or header layer does not equal layer, then go ahead and return false. Otherwise, record equals load record, which is going to be another method that hasn't been implemented yet. We're going to pass in the type, the header, and the reader, and then we're going to return true to signal to the walk record list that we need to stop looping through all of our records.
Okay.
Finally, we just return out record. If record was never found, he's going to stay as null. If he is found, he's going to be the value of whatever load record is. So yeah, that's actually the entire logic behind the get method. It more or less reads exactly like the description we had in the Photoshop document, which was the point of this method, just to, stuff and things.
Did you want to go ahead and stub out the walk record list and load record?
Oh yeah, just create them.
Yeah.
This is actually going to be, the first argument is going to be a record header. The second argument is going to be a binary reader. And this is going to be called on next record. And then we'll have a record load record method, which is going to return an I record. It gets a type, a header, and a reader.
Cool.
And I'm going to stick this guy under this guy and store above both of those.
And you know what? And since we're about to start taking a look at store, we're about 10 minutes in. This is a good place to go ahead and just stop right here, pick up in the next video. Is that good with you?
Okay.
Okay. All right. Well, we'll wrap things up here. Again, guys, I'm just trying to stay on keeping these videos nice and short and concise. So we will catch you back in the next video. Thanks a lot.